Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of wavelength division multiplexing. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of time division multiplexing, a multiplexing technique by which multiple data signals can be transmitted over a common communication channel in different time slots is known as time division multiplexing or TDM. The time division multiplexing or TDM may be used with both digital and analog signals. That means, in short, we can say that the time division multiplexing is a multiplexing technique in which any signal, that means any digital signal or analog signal, can be transmitted over a communication channel in a different time slots. Here, the word different time slots is very important. Okay. In TDM, all the signals to be transmitted are not transmitted simultaneously. Instead, they are transmitted one by one. Thus, each signal will be transmitted for a very short time. Let's see the principle of the TDM. Here is the diagram for the principle of the TDM is shown. One transmission of each channel completes one cycle of operation called as frame. That means in TDM, the signals are not transmitted simultaneously, but they are transmitted in the form of units. That means here the signal 1 unit, signal 2 unit, signal 3 unit, and signal 4 unit are transmitted in one cycle. Hence, this one cycle is known as one frame. That means in TDM, the data is transmitted in the form of frame. Okay, I hope you all understand the concept here. Let's see once again, in time division multiplexing, the data is transmitted in cycles, and here the cycle is known as the frame. Okay, one cycle or frame is said to be complete when all the signals are transmitted once on the transmission channel. Okay, let's see TDM working principle. Okay, here is the detailed TDM working principle is shown. In this diagram, we can see here that there are three sources, source 1, source B, and source C. That means these are the source of the input signals. The signals may be analog or digital in nature. Okay, these signals are multiplexed in the multiplexer and they are transmitted over a communication channel in the form of different frames. Okay, let's see the details about each one by one. The data flow of each source A, B, or C is divided into units, say A1, A2, B1, B2, etc. That means each source is divided into unit, such as source A is divided into A1, A2, A3. Source B is divided into B1, B2, B3. Source C is divided into C1, C2, C3, depending upon the time slots. Then one unit from each source is taken and combined to form one frame. Okay. Then what happens here? One unit from each source, that means source A, we take here A1, from source B, take B2, and from source C, take C1. Okay. Hence, the bits A1, B1, and C1 forms one frame and it is transmitted A1, B1, and C1. The next frame is A2, B2, and C2. The frame 2 is A2, B2, and C2, and the frame third is A3, B3, C3. A3, B3, C3. This is the frame third. I hope you all understand the concept of time division multiplexing. The size of each unit, such as A1, B1, etc., can be 1 bit or several bits. The TDM signal in the form of frames is transmitted on a common communication channel. Okay, I hope you all understand the working principle of time division multiplexing. Let's see once again. There are three sources, source A, B, and source C. These sources are divided into the units, for example A1, A2, A3, B1, B2, B3, C1, C2, C3. Each unit is transferred in the same time. That means A1, B1, C1 forms a frame 1 and it is transmitted over a common communication channel. The frame 2 is made up of A2, B2, C2. Frame 3 is made up of A3, B3, C3, and these frames are transmitted towards the receiver through a common communication channel. Okay, let's see in details. Here is another diagram of time division multiplexing is shown, in which the sources, there are total 4 sources A, B, C and D. Okay, A, B, C and D. These 4 sources are multiplexed in a multiplexer and they transmit over a common communication channel towards the receiver. Here, the demultiplexer demultiplexes it and separates the signals. Okay, let's see how this process is done. For example, first of all, transmit bit A. This is bit A. Then next transmit bit B. Transmit this B. Then transmit this C. Transmit this C, and then at last transmit this bit D. Okay, that means this is the one frame. Okay, that means this is the one frame. Again, after the transmission of this frame, the second frame is transmitted. The second frame is A, B, C, D. Okay, this is the second frame. I hope you all now understand the time division multiplexing working principle. Now, let's see the type of time division multiplexing system. PAM TDM system, that means pulse amplitude modulation time division multiplexing system. The operation of the system is as follows. Here is the block diagram for PAM TDM system is shown. In this diagram, we can see that there are n number of input signals, that means x1t, x2t, xnt, and these are connected with the commutator, that means connected with the multiplexer through a low pass filter, and these low pass filters are having the center frequencies with respect to the input signals. Okay, then the multiplexer selects any one of the signal depending upon its position, and the signal is transmitted over a communication channel through a pulse amplitude modulation block. At the receiver, the pulse amplitude demodulation process is done, and the demodulation process is done to separate out the original signals. Let's see the detailed operation about this diagram. Here, the multiplexer here is the single pole rotating switch or commutator. That means this commutator is a multiplexer. It can be mechanical switch or any electronic switch. Okay. Now, as the switch arm rotates, it's going to make contact with the positions 1, 2, 3 or n for short time. That means if we rotate this switch, then depending upon the switch position, the x1 signal, x2 signal, x3 signal or the xn signal is connected with the common communication channel or the pulse amplitude modulation block. Okay. Thus, the switch arm connect to these n input signals one by one. As shown in the waveform, the rotary switch samples each channel during each of its rotation. That means, as shown in the waveform, the pulse amplitude modulation is done. Okay, depending upon the various time slots. Each rotation corresponds to one frame. That means if one rotation is completed, then we can say that one frame is completed and this frame is now transmitted towards the receiver. At the receiver, there is one more rotating switch or commutator used for demultiplexing. This is the another rotating switch used for the demultiplexing purpose. Okay, I hope you all understand the PAM TDM system. Now let's consider some important terms about the time division multiplexing system. The first one is signaling rate, and it is shown by the symbol small r. The signaling rate of TDM is defined as the number of pulses transmitted per second. That means in 1 second, how many pulses are transmitted. This This is known as the signaling rate and it is denoted by small r. The next term is transmission bandwidth of a TDM channel. The minimum transmission bandwidth of a PAM TDM channel is given by Bt is equal to 1 half into signaling rate, that means 1 half into R. Okay. Now let's see the types of TDM. There are mainly two types of TDM. First one is synchronous TDM and second one is asynchronous TDM. Let's see the details about each type one by one. First one is the synchronous TDM. In synchronous time division multiplexing, each device, that means transmitter, is allotted with the fixed time slot, regardless of the fact that the device or the transmitter has any data transmit or not. The device has to transmit data within this time slot. If the device or the transmitter does not have any data to send, then its time slots remains empty. It is used for multiplexing digitized voice stream. That means in synchronous time division multiplexing system, the time slots are fixed. Okay. For example, let's consider this diagram. Here there are total 4 sources A, B, C and D. Here are total 4 sources, hence the length of the frame is also a 4 bit. Okay, I hope you understand the concept here. Let's see once again. There are total 4 sources A, B, C, D. Hence the length of the frame is made up of the 4 bit. That means if we consider the multiplexing technique, then first this A is transmitted, then B is transmitted, C is transmitted and D is transmitted, and this is the one frame of the TDM system. Okay, the next frame is A. Here the B is absent, C is absent and then D. Here is A, then B is absent, C is absent and then it transmit D. That means there may be some empty slots available in synchronous time division multiplexing technique. I hope you all understand. Let's see once again. In first frame it transmits A B C D. It transmits A B C D, and in second frame it transmit A, then empty space B, D, A, empty space, and then D. This is the second frame. Okay. Now let's see the asynchronous TDM or statistical TDM. In asynchronous time division multiplexing, the time slots are not fixed. That is, the time slots are flexible. The asynchronous TDM is also known as statistical time division multiplexing. In synchronous TDM, the number of time slots is equal to the number of devices or the transmitter. That means in synchronous TDM, the number of sources is equal to the number of bits in the frames. Okay. But in asynchronous TDM, the number of time slot is not equal to the number of devices or the transmitters. The time slots in asynchronous TDM are always less than the number of devices or transmitter. Let's see here in this diagram we can see here that there are also 4 sources A, B, C and D. There are total 4 sources. If this is the synchronous system, then the frame is made up of 4 time slots or 4 bits. But here in a synchronous system there are 4 sources, but the frame is made up of 3 time slots or 3 bits. Okay, this is the basic difference between asynchronous and synchronous TDM. In asynchronous time division multiplexing, time slots are not fixed to a particular device. Instead, they are allotted to any of the devices that have data to send. All the time slots in the frame are completely filled. This is the very main difference between asynchronous and synchronous, is that in synchronous there may be some empty time slots. Okay, let's see once again. In synchronous there may be some empty time slots, but in asynchronous TDM there is no any empty time slot in the frame. Okay, let's see the diagram of the asynchronous time division multiplexing. Here The four sources are present: A, B, C, and D. These sources are multiplexed in a multiplexer through in a communication channel. It forms a frame. The size of the frame is not equal to the size of the sources. That means there are four sources, but the time slots or the bits are three in a frame. Okay. Here, first this A is transmitted, then B is transmitted, and then C is transmitted. Here is the frame 1 is complete. The second frame starts with this D is transmitted, then this A is transmitted, and this D is transmitted. That means there is a continuous transmission of frame is happen, and in this case there are no empty spaces in the frame. Okay, I hope you all understand now the asynchronous time division or statistical time division multiplexing technique. Now let's see some advantages of time division multiplexing system. In time division multiplexing system, the full bandwidth is utilized by a user at a particular time. The second advantage is that the time division multiplexing technique is more flexible than frequency division multiplexing technique. The third advantage is that in TDM, the problem of crosstalk is very less, and the fourth advantage is that the TDM has the simple circuit design. There are some disadvantages of the TDM such that in TDM, the transmitting and the receiving section must be properly synchronized in order to have proper signal transmission and reception. That is, in TDM, the synchronization is required. The second disadvantage of the TDM is that in TDM, the slow narrowband fading can wipe out all the TDM channels. Okay. Let's see the applications of the TDM. TDM finds its application mainly in a digital communication system, in cellular radio, and in satellite communication system. I hope you all understand the time division multiplexing technique. Now, here in this diagram, we can see here that there are three multiplexing techniques. First one is frequency division multiplexing, second is time division multiplexing, and third is wavelength division multiplexing. In frequency division multiplexing system, we can see here that there are three input signals, and these three input signals are transmitted towards the receiver or towards the demultiplexer in a communication channel. Okay. In time division multiplexing system, there are four input signals. That means there are four input signals, and these input signals are transmitted in the form of four bits or time slots. Okay, that means in TDM, the input signals are transmitted in the form of frames, and frame is made up of the different time slots taken at the different interval of the input signals. Okay, and in wavelength division multiplexing, the different wavelengths are multiplexed in a single communication fiber, and it is transmitted towards the receiver or towards the demultiplexer. The basic difference between the three types is here that FDM, that means frequency division multiplexing, has multiple data signals combined for a simultaneous transmission via a shared communication medium. TDM allows multiple users to send signals over a communication channel by allotting a fixed time slot for each user. Wavelength division multiplexing modulates data streams, optical carrier signals of varying wavelength into a single light beams via a single optical fiber. FDM uses analog signals, TDM uses digital and analog signals, and WDM uses optical signals. Okay, this is the basic difference between frequency division multiplexing, time division multiplexing, and wavelength division multiplexing. Let's see the detailed difference between the frequency division multiplexing and time division multiplexing. The first difference is that in frequency division multiplexing, the signals which are to be multiplexed are added in time domain, but they occupy different slots in the frequency domain. Okay. In TDM, the signals which are to be multiplexed can occupy the entire bandwidth of the time domain. FDM is usually preferred for analog signal, while TDM is preferred for digital signal, and in TDM we can also transmit the analog signal. Okay. In FDM, synchronization between transmitter and receiver is not required, while in TDM, the synchronization between transmitter and receiver is required. This is the necessary that the synchronization between the transmitter and receiver of the time division multiplexing. The FDM requires a complex circuitry at TX and RX. TDM circuitry is not very complex at transmitter and also at the receiver. FDM suffers from problem of crosstalk due to imperfect bandpass filters. In TDM, the problem of crosstalk is not served. In FDM, due to bandwidth fading in transmitter medium, all the FDM channels are affected. In TDM, due to fading, only few time division multiplexing channels will be affected. In FDM, due to slow narrowband fading takes place in the transmission channel may be affected in FDM. In TDM, due to slow narrowband fading, all the TDM channels may get wiped out. This is the difference between frequency division multiplexing and time division multiplexing. I hope you all understand the contents discussed in this lecture. Thank you.